So finally, once the basic concepts related to the production system are clear, and also we have explained which are the main classification dimension, we can deep dive more into the technological aspects and the understanding of which are the possible options for production system organization. First of all, I mean, just to make this clear, manufacturing process can be distinguished in two types: processing or manufacturing operation and assembly operation. I mean, I don't want you to go too much in technical details, but processing operation can be shaping processes, so process that gives shapes, property enhancing, so process that gives some properties to the material they are processing, or surface processing, so like for example some surface straightening or surface painting and so on. And here you see, I mean, just some example of operation that falls within this kind of categories. Assembly operation instead can be essentially joining processes, so putting together different components, or mechanical fastening. So just to give you an understanding of the technical aspects that the production process needs to be managed. According to this view, of course, as a product can be realized through manufacturing and or assembly operation, there will be options to organize both activities, and companies can just have a manufacturing production organization, an assembly production organization, or both. In particular, when we talk about manufacturing activities organization, these are the options, so job shop, manufacturing cells, and transfer lines. When we talk about assembly assembly activities organization, the options are fixed position, assembly shop, and flow shop. Let's deep dive on these, starting from manufacturing. So again, possible options for manufacturing are job shop, manufacturing cells, and transfer lines. First of all, let's clarify what manufacturing systems are. I mean, manufacturing systems are that part of the production system where irreversible and morphological transformation of raw materials and components take place. So, through manufacturing system, we process raw materials and we reshape them in order to reach to be near the final configuration of the finished product. Of course, to execute manufacturing operation and in manufacturing system, it is essential to have good technology and good machinery. So there is high relevance of the technological parameters of the system, and in particular, I mean, the design of the process is the core part of manufacturing system. So how the manufacturing process is executed and which resources execute this process. And while instead, at this level, the technological parameter of the process, of the product, are just in background. More, in manufacturing system is where math, analytical model are more diffused in order to analyze, schedule, control production activities, because they are essentially technological and machinery driven. If it is true, in manufacturing system, multiple resources are present, like operators, machines, tools, programs, and so on. And of course, they need to be organized in a proper way, because they need to be very well integrated. Machineries are the main actors usually in manufacturing system, but need to be assisted by operator, and they need tools and equipment to be used, so all need to be well synchronized in the system, and this is defined at the managerial level. However, despite the huge number of resources that are present in this type of system, fixed capital, naming machineries, assets, is the predominant cost item of this part of production, and it is in manufacturing system where most of the production fixed costs are determined, meaning depreciation and amortization. Example of manufacturing activities again are mechanical working like lathe, pressing, plastic, and metals. The first option to realize a manufacturing system is what we call a job shop. With this choice, essentially, in our system, we see different work centers. Remember the concept of work center. Each one having inside machinery grouped with according to technological affinity, meaning able to execute similar operation. See this example. We have 8 work centers: cutting, planing, shaping, assembling, sanding, finishing, drilling, and turning. And inside each work center, some machinery are included, and all the machineries are able to execute the work center characteristics. So here we will have different machineries able to execute cutting. Here we will have a series of machinery able to execute planing. Here, a series of machinery able to execute shaping, and so on. So each product, this is a product, enters the job if it needs the operation, and will be allocated to a particular machine according to the planned schedule. So in this case, the product enters and needs cutting, then needs planing, then goes to drilling, then goes to turning, then go to assembly, sanding, and finishing. It doesn't need shaping. So this means that of the 8 available jobs, product one will go through 7 of them, while instead product 2 doesn't need drilling and go through cutting, planing, shaping, turning, assembly, sanding, and it doesn't need even finishing. So it will use 6 out of 8 jobs. In this case, you see that work centers are grouped with similar machinery, and product cross machineries, cross the jobs according to the operation that they need. In this system, of course, as you can see from the previous representation, flows are extremely interwoven because different products may pass through the same job. Labor is often the critical limited resource because an operator needs to supervise many machinery present in each job. So the human workforce is the very critical resource to make the system function properly. Product may spend most of the time waiting or queuing to be processed by machines in the job shop because, there are different products requesting the execution of the activities within the same jobs, and for this reason there may be alternative cycle or routings defined for the different products in order to try to minimize possible queue and waiting times. The second option for the manufacturing system are manufacturing cells. This second approach is totally different from the job shop one. Because manufacturing cells are groups of machineries or people that are grouped in a way that makes the manufacturing process more efficient. As you can see from this representation, in a manufacturing cell, we have all the resources, machineries, operators, tool, equipment that are needed to manufacture the product from the first to the last operation. So you can see the product enters here, encompass all the operations that are needed to manufacture it, and then exit the manufacturing cells. A product enters a cell and passes through all the operations that are needed to manufacture it. So cells are production system or subpart of the production system which are dedicated to specific product families or model. So there are no flows among cells because only products which are of the same family goes through the same cell, and each cell is dedicated to the manufacturing of just one type of family of products. An alternative option to manufacturing cells are what we call transfer lines. Transfer lines are manufacturing systems which are still dedicated to a production of a specific family or model of product, but you see here the organization doesn't look like as a cell anymore, but the different activities and operation are organized in line sequential stages, and at each stage we find machines, we find operators, we find tools, we find equipment that are needed to realize a specific activity. So each line is allocated to a specific product family or model. A product enters the line here and exits the line here by executing all the activities that are needed to manufacture them from the first to the last operation, but the organization, the physical organization of this system is in line. This is very useful because the line helps to keep production pace extremely high. However, compared to a manufacturing cell, this is much more a rigid system, as dismantling a transfer line and reconfigure it for producing other type of family or products is very difficult. So here you have a high production rate, but also a rigid system. So you need to keep on producing this family of model of product because reconfiguring a transfer line is very difficult. Here you can see how to choose from an option to the other according to two dimensions that are typical of production. So the volume to be produced and the variety of product that need to be realized. So how many how many models or families the production system need to manufacture. You can see that when the volume is high and the variety is relatively low, the configuring transfer lines could be a good choice. Could be a good choice as they are product focused and dedicated system, and they are designed in order to satisfy a huge production volume at high pace. While instead, when the product variety is higher, using a product-focused system could be really complex. So the job shop represents the most efficient solution. However, due to the difficulty in coordinating and scheduling product flows among the shops, of course, production volume should not be so huge because otherwise managing this type of system will be very complex. In hybrid situations, so when we have relevant but not super high production volume and large but not super large variety, manufacturing cells represent the best option, as they are also able to guarantee some system flexibility in case some reconfiguration of the system is needed, so making the cell able to produce other model of product and vice versa. Let's now switch to the assembly system. Again, within assembly system, we can distinguish between fixed position, assembly shop, and flow shop. Let's first start again with describing some general characteristics of assembly system. Assembly systems are designed to manage assembly activities, which, I mean, generally speaking, are putting together components and modules that are already been manufactured in order to obtain the final product. So, in comparison to manufacturing activities, which were mostly process driven, in this case organization and assembly activities are driven by the technological parameters of the product, which influence how assembly is made, and of course the process, I mean the technological aspect of the process goes in background. Even if we are in a context which is technological advanced and so on, most of the activities in an assembly system are still very human dependent. So most of the costs related to assembly system and assembly activities are determined by human labor and manual operation. So a proper organization of these activities is fundamental. So where to put each operator, which are the competencies, which are the rules, and so on, because these organizations clearly affect the quality of the final product. Think about some industries as automotive or electronics. Car, washing machines, computer, phones are all products configured through assembly activities, and the way assembly is organized and carried out clearly affect the final configuration and the final quality of the product. The first option that we can use to organize the assembly activities is what we call the fixed position systems. The fixed position systems is typical of construction site and for the assembly of very big and heavy products like aircraft, like trains, like planes. In a fixed position layout, personnel, supplies, equipment, tools, materials, or whatever are brought to the site where the product will be assembled. Rather than making the product moving through the assembly line and passing through the different assembly stations. And you can see here you see the example of how an aircraft is made. So it is fixed in its position, and all the human resources, all the capital, all the materials are brought into the space where the aircraft is stored in order to assemble it and making the final configuration. This is very helpful because brings high system flexibility, because it helps both introduce new products. So introduce new product is very easy because you just have to bring different resources in the space where you want to build the product, but also to obtain product customization, because it's just a matter of using different material according to the product we are assembling. Of course, the drawbacks of this choice is the realization of high work in progress, because I don't know if you know, but these aircraft can be realized in months. So it means that for months I have work in process, so capital stocked on the assembly line, so in the fixed position, and also in order to do that, a significant space occupancy is determined, and of course availability of space is required. A second option is instead what we call the fixed transfer assembly line, which was concept is similar to the manufacturing assembly line. In this case, machine, tools, workers are arranged in sequential stages in which the product is assembled by having each of one performing specific successive assembly operation. So as you can see here, the product entered the line here and passed through the different station, and each station is supposed to execute a different assembly operation. In the most automated fixed transfer line, the stations are linked by a transportation system through which the product in progress is transported. So after a certain time lag, which is named the line cycle time, the transport system transfers the sub-assembled part from one station to the following one. So after 1 minute, the execution time of this operation is 1 minute. After 1 minute, the product is brought to the work in progress product is brought to the following station. Of course, different type of assembly line exist, and they can vary both in the nature of the activities executed, but also in the technology used to support assembly activities. In this first example, you can see a photo of an assembly line for airplanes and engines. In this line, sophisticated tools and equipment supports operator in configuring the final product. On the right, instead, you see the assembly line for diamond jewelry. Assembly line for diamond jewelry is made by simple workstations where the several operators have simple tools and materials that are needed to execute the activities to arrive to the final product. So, same organization, different technological complexity according to the characteristic of the product. Then finally, we have the concept of shop for assembly line. For assembly system, in particular, we have assembly shop and assembly job shop and flow shop. Let's start with assembly job shop. The assembly job shop reflects the same ideas of the manufacturing job shop, because the assembly job shop groups workstations and machineries which have an activity affinity in terms of nature of the activity to be executed. So as you can see here, these are assembly job shop. You see 1, 2, 3, 4, 5. Operators, machineries, and tools are grouped according to the nature of the activity that they have to execute. So people here are grouped because they are supposed to execute a similar assembly operations, and so on. So the concept is the same as the manufacturing job shop, with the difference that here we are talking about assembly operation, so the organization and the grouping is not about on technological affinity, but the nature of activities that operator need to execute. While instead, a flow shop is no other than an assembly cell. The flow shop is no other than an assembly cell for the assembly system. So in the flow shop, there are all the operators and all the resources which are needed to perform the assembly activities of a single product. Again, this is a flow shop for product 1. We have 3 workstation A, D, B, and these workstations are needed to assemble the product in its final configuration. Same for 2. This is the flow shop for product 2, where we have C workstation, B workstation, and A workstation, which are needed to bring the product in its final configuration through different assembly activities. Again, also for assembly activities, we can see how to choose which are possible driver of choice from one option to the other according to product volume and product variety to be realized. You can see that when the volume is high and the variety is relatively low, the fixed transfer lines is a good choice as, fixed transfer lines are focused and are product focused and dedicated, and they are designed in order to satisfy a huge production volume and eyepiece. Because it's in the concept of line, the fact that they can support fast volume and fast production rate. While instead, when the production variety is high and the volume is low, or at least is unique in the different products that need to be realized, like in the case of aircraft, helicopters, machinery, and so on, fixed position is a good choice because it's able to allow customization and flexibility, so it allows company to realize activities, assembly activities, which also very different in nature, but of course to be sustainable the volume should be not so high. While instead in hybrid situation, so when we have relevant but not super high production volume and large but not super large variety, assembly shop and flow shop are suggested. In particular, when there is a predominance or product line width, assembly shop are more suggested, while instead when it is the production volume, the variable which is higher than the other one, flow shop are the best, may represent the best choice. To conclude this part, with this perspective, we can essentially conclude that when we talk about production system, we can distinguish essentially two types of approach in organizing this kind of system. The first one is what we call the process-focused production organization. The process-focused production organization use input criteria to group resources, as all the operations are grouped according to the type of process. The products move from one department to the other, so to one workstation to the other, in small batches, which are determined by the customer order. And job shop and manufacturing job shop and assembly job shop are example of systems using this approach. As we see, input criteria, we group machineries or activities executed according to their nature, input criteria, so they are process driven, which is totally different from product focused organization, which use output criteria to group production resources, machineries and human workforce. And in this type of process design, product and services flow along a linear path in a shared space, and they follow similar production sequence. So we have resources which are grouped with an output approach, so in order to execute all the activities that are needed to manufacture and assemble a final product. This is essentially a product-focused production organization. The fixed position solution instead try to combine both perspectives, but of course it's only applicable to certain products. We saw like some very big product, heavy product, or for construction, for product that can be executed in construction sites. Finally, just to conclude as example, here you can see some example of product from different industry and the characterization of their production system. Some of them have been already discussed in previous example, but I mean, if you consider suits, for example, they are realized in make-to-stock using an approach in manufacturing system, which is a job shop, and assembly, which are realized through assembly shop. So they are totally a process-focused organization, which is different, for example, to the realization of ship. Ship use an engineer-to-order approach when the manufacturing is realized through job shop for some specific parts that, however, comes from suppliers. So ships realization is essentially an assembly into industry, but in a construction site where ships are assembled and realized, there is also a manufacturing part for some components like the wheels or some of the cabin, which are realized in using a job shop approach, while instead the realization of the big ship is done using a fixed position system, or again, if you consider phone manufacturing, of course, companies like Apple and Samsung doesn't manufacture anything. They just assembly components coming from different suppliers, and the assembly is organized in assembly lines. So different family of phone see dedicated assembly line. Then once the product has been realized and assembled, there can be some manufacturing operation to be executed, like refining operation, surface treatment, painting, which are organized in cells, and so on. Then you see again water is relied in make-to-stock system, and particular in the process industries, which sees manufacturing transfer lines, while washing machine use a job shop in manufacturing for some parts refinement, like surface and painting, while instead they use assembly line, dedicated assembly line to assembly all the components.